What would you do if your children were born blue, not oxygen, deprived blue, not bruised blue, but a deep, permanent indigo that ran through their blood like a curse written in their very cells? Welcome to this journey into one of the most extraordinary medical mysteries in American history. But before we descend into these isolated mountains where science collided with superstition, I need you to ask yourself, when does difference become disease? When does a family's secret become folklore? Tell us where you're watching from right now and whether you believe isolation protects us or destroys us, because by the end of this account, you may question everything you thought you knew about community, survival, and the strange boundaries between myth and medicine. In the medical archives of the University of Kentucky, there exists a photograph that shouldn't be possible. A family portrait from 1960 where every face shows the same impossible shade. Blue, not painted, not filtered, not doctored, blue. The blue of a vein seen through pale skin, but magnified, intensified, spread across entire bodies like some biblical plague that refused to kill but also refused to leave. We're about to delve into a mystery that spans 6 generations, where one French orphan's arrival in the Kentucky mountains in 1820 triggered a genetic cascade so rare that it appeared nowhere else on Earth, creating a family so visually distinct that they became legend, so medically unique that they baffled doctors for 140 years, and so isolated that they nearly vanished before science could explain what had made them blue. This isn't just a story about genetics. This is a question about what we do when we can't explain what we see, when the evidence of our eyes contradicts everything we believe possible. It was the year 1820. James Monroe was president, Missouri was becoming a state, and the frontier was still wild, lawless, and willing to swallow people whole. But into the remote mountains of eastern Kentucky came a man named Martin Fugate, a French orphan with skin so pale it seemed almost translucent, carrying nothing but the clothes on his back and a secret hidden in his blood, a recessive gene so rare that it should have died with him, lost in the vastness of American bloodlines. Instead, through a series of coincidences so improbable they seem almost designed, that gene would flourish, multiply, and create something the world had never seen. An entire family whose blood literally ran blue. The thing about Troublesome Creek is that even the name warns you. Not Peaceful Creek. Not Promise Creek. Troublesome. As if the first settlers looked at these mountains razor-backed ridges that cut the sky into pieces, valleys so deep and narrow that sunlight only reached them for a few hours each day, forests so thick you could vanish into them and never be found, and knew that survival here would cost something, that the land itself was a bargain you made, trading connection to the wider world for a kind of freedom that tasted like loneliness. This is Perry County, Kentucky, eastern Kentucky, Appalachia at its most remote. Even today, these mountains resist easy access. In 1820, they might as well have been another planet. The hollers, that's what locals call the valleys, those narrow clefts between mountains where communities clung like moss to rock, were so isolated that families might go months without seeing anyone outside their immediate kin. The nearest town was a day's ride on horseback over trails that could kill you in a dozen ways. Rockslide, mudslide, flash flood, hypothermia, a thrown shoe that left you stranded in wilderness, where help was a concept, not a certainty. Into this isolation, people brought their genetics, their blood, their secrets, and sometimes, in the strange mathematics of reproduction, those secrets multiplied. The year Martin Fugate arrived in Kentucky, the mountains were filling with people like him. Refugees from failed farms, younger sons with no inheritance, criminals fleeing justice, religious separatists seeking freedom, French refugees from failed revolutions, people who needed to disappear, People who wanted to be left alone. People who, for 1,000 different reasons, chose distance over community. Martin was 19 years old, an orphan, French, though no records exist of exactly where in France or how he made the journey to America. The few documents that mention him describe a pale man, unusually pale even by the standards of Europeans who'd spent their lives indoors. Pale skin, pale eyes described sometimes as blue, sometimes as almost colorless, like water over ice. He settled on the banks of Troublesome Creek and built a cabin from the abundant timber. In these mountains, if you had an axe and determination, you could create shelter. Survival was harder. You needed land cleared for crops, animals for food, salt for preservation, a wife for children, because in the wilderness, family was the only insurance policy that existed. Martin found that wife at a church meeting in Hazard, the county seat. Her name was Elizabeth Smith. Here's where the story takes its first dark turn into impossible mathematics. Elizabeth Smith was not blue. By all accounts, she was a typical Scot, Irish woman of the Appalachian frontier, hardy, pale, skinned like most mountain people of European descent, brown, haired, strong enough to work a farm. Nothing in her appearance suggested anything unusual, but Elizabeth carried something invisible, something that wouldn't manifest unless it met its exact mirror in someone else's blood. She was a carrier of the same recessive gene that Martin carried. The odds of this are staggering. Let me make them clear. The gene in question. We now know it as a mutation in the CYP5A1 gene that produces an enzyme called cytochrome B5 methemoglobinemia reductase, is extraordinarily rare. So rare that it appears in perhaps 1 in 100,000 people. The chance that two carriers would meet in the general population is virtually impossible. The chance that they would meet in isolated frontier Kentucky, marry, and have children. It should never have happened. But it did. And when recessive genes from both parents combine, the trait doesn't just carry. It expresses. It becomes visible. It becomes real. Martin and Elizabeth Fugate had 7 children. 4 of them were blue. Imagine Elizabeth's terror. You've given birth before. You know what a newborn should look like. Red-faced, squalling, the skin gradually pinking as blood pumps through new lungs. You know the sounds a midwife should make. Encouraging, competent, routine. But when your first child emerged in 1821, the midwife didn't make routine sounds. She made a gasp, a sharp intake of breath that meant something was wrong. And when Elizabeth demanded to see her child, she understood why. The baby was blue, not the dangerous blue of oxygen deprivation, the cyanotic blue that meant death was coming. This was different. The child was breathing, crying, moving with all the vigor of healthy infancy. But the skin was the color of a bruise, the color of a vein, the color of sky reflected in deep water. Blue. In that cabin on Troublesome Creek, lit by firelight and oil lamps, with wind rattling the shutters and the nearest doctor a full day's ride away even if you could convince one to come, Elizabeth held her blue child and had to choose. Was this a curse, a demon, a punishment from God, or was it simply strange, inexplicable, but not necessarily dangerous? The child thrived, nursed normally, grew. The blue didn't fade. Martin, we can imagine, recognized something. Perhaps he'd been told family stories. Perhaps he'd seen faded daguerreotypes of relatives in France whose skin tones seemed off, whose portraits had been touched up, whose existence had been whispered about. Perhaps he'd always known he carried something different in his blood. Or perhaps he was as terrified as Elizabeth. But they had a choice to make. In the isolated hollers of Kentucky, where communities were small and everyone knew everyone's business, where difference meant suspicion and suspicion could mean exile or worse. They could have hidden the child, could have claimed it died, could have sent it away. They didn't. They kept the child, raised it, and when they had more children, 7 total, 4 of them blue, they raised them too. The Fugates were becoming a family marked by something no one could explain. Here's what we know about those early Blue Fugates from the fragmentary records that survive. They were healthy. Let me emphasize this because it's crucial to understanding what came next. Despite their shocking appearance, the Blue Fugates were not sick. They didn't die young. They didn't suffer from obvious disabilities. They could work farms, raise families, survive the brutal demands of frontier mountain life. The blue was cosmetic, but cosmetic in a way that marked them as other, as wrong, as fundamentally different from everyone around them. The oldest blue child, a boy, grew to adulthood and married. His wife was not blue. Their children, here the genetics become fascinating, were not blue either. When one parent is blue, having 2 copies of the recessive gene, and one parent is normal, having no copies, all children become carriers. They look normal, but they can pass the trait forward. The second blue child, a girl, also married within the mountain community. Her husband, we now know from genetic analysis done in the 1960s, was likely a distant cousin, someone who carried the gene without expressing it. Some of their children were blue, and here's where the isolation of Troublesome Creek becomes medically significant. In most populations, a rare recessive gene would disperse. Blue children would marry into families from other regions, other states, other gene pools. The trait would dilute, scatter, eventually vanish. But in the hollers of Perry County, in the closed social circles of isolated mountain communities, people married who they could meet. And who could they meet? Neighbors, people from the next holler over, distant cousins who might not even know they were related. The Fugate gene didn't disperse, it concentrated. By 1850, 3 generations removed from Martin and Elizabeth, there were scattered blue individuals across multiple family lines in Perry County. The Fugates, the Smiths, the Comses, the Stacys, all interconnected by marriage, all carrying the gene, all occasionally producing children whose skin bore that impossible indigo shade. The locals developed a term for them. They called them the Blue Fugates. Sometimes, less kindly, the Blue People. Children were warned not to stare. Adults developed a studied politeness that involved not mentioning the obvious. Because what could you say? In an era before modern medicine, before genetics, before any scientific framework for understanding inherited traits, the blue skin was simply a fact. Like some families had red hair, some had blue skin. It ran in the blood, and in the insular world of Troublesome Creek, it ran deep. By the late 1800s, the Blue Fugates had become legend. Stories spread beyond Perry County. Traveling preachers mentioned them. Circuit court lawyers who passed through Hazard carried tales of the Blue People back to Louisville, to Lexington, to Cincinnati. The stories grew in the telling, as stories do. Some said the Blue People had gills, that they could breathe underwater, that they were descendants of drowned sailors, of river spirits, of demons who'd taken human form, that they practiced dark magic in the hollers where no outsiders went. None of this was true, but truth matters less than narrative when communities are trying to make sense of the inexplicable. The Fugate descendants, and by 1900 there were dozens of people carrying the gene across multiple family lines, developed their own strategies for survival. Some isolated themselves further, moving deeper into the mountains where strangers were rare. There were hollers where entire extended families lived, where blue children could grow up seeing other blue children, where the trait was normal because everyone was family and family meant sameness. Others tried to integrate. They married out when possible, hoping to dilute the gene. They developed thick skins against stares and whispers. They worked twice as hard to prove their competence, because they knew they'd be judged first by their appearance. And some just vanished from the historical record entirely. One family line moved west to Oregon in the 1880s. Whether they remained blue or whether distance, and new gene pools eliminated the trait, we don't know. They stopped writing home, stopped sending letters, the connection severed. Another branch moved to Ohio, settling in industrial towns where strangers were common, and no one asked too many questions if you worked your shift and kept to yourself. But the core population remained in Perry County, on Troublesome Creek, in the hollers with names like Ball Creek and Caney Creek and Lost Creek, names that suggested the landscape itself was a maze you could wander forever. And there, in that isolation, the blue gene persisted. The early 1900s brought roads. Not good roads. Mountain roads were treacherous, washed out by rain, blocked by snow, barely more than cleared paths. But roads nonetheless. With roads came occasional cars. With cars came a slow, reluctant connection to the wider world. Medical knowledge was advancing. Doctors were beginning to understand blood, circulation, oxygen exchange. They had microscopes, chemical tests. The framework for understanding why blood was red, oxygenated hemoglobin, and what could make it blue, methemoglobinemia, literally blue blood. But this knowledge existed in universities, in teaching hospitals, in urban medical centers. It had not yet reached the hollers of Perry County, where medical care meant a neighbor woman with experience in childbirth and a store of herbal remedies passed down through generations. The Blue Fugates continued to have children, blue children. In 1910, a census taker noted in his records, family of unusual appearance, skin shows blue coloration, health appears normal, no follow-up, no investigation, just a notation in a ledger that would sit in archives for 50 years before anyone thought to look. In 1920, a newspaper in Hazard ran a brief story about the mysterious blue people of the mountains, treating it as local color, folklore, a curiosity to amuse readers. The story described the Fugates as secretive mountain folk who avoid outsiders, and suggested the coloration might be from drinking mineral, rich water, or exposure to some unknown plant. None of this was true, but the Blue Fugates weren't interviewed for the article. They weren't consulted. They were subjects, not sources. The Great Depression hit the mountains hard. People who were already poor became desperate. Young people left for factory work in Detroit, Cincinnati, Chicago. The population of Perry County declined. But some Fugates remained. Always some remained, and in 1948, something happened that would eventually bring the truth to light. A woman named Luna Fugate Combs gave birth to a son. His name was Benjamin Stacy, and he was the bluest person anyone had ever seen. The nurse at the Hazard Hospital had worked delivery rooms for 15 years. She'd seen jaundiced babies, premature babies, babies with birthmarks and cleft palates, and every variation of normal human infant anatomy. She had never seen a blue baby who wasn't dying. When Benjamin Stacy emerged in 1948, his skin was the color of a blue popsicle. Not the pale blue of oxygen deprivation, not the mottled blue of poor circulation. This was uniform, intense, undeniable blue. The medical staff panicked. Oxygen was administered. Tests were run. The infant's blood was drawn, and here's where the first clue should have emerged. Because the blood itself was unusual in color, darker than normal, with a strange brownish tint. But the infant was breathing normally, heart rate normal, all vital signs normal, except for the color. The doctor on duty made a call to the University of Kentucky Medical School in Lexington. "I have an infant presenting with extreme cyanosis," he reported, "but all vitals are normal and the condition is not responding to oxygen therapy." The response was immediate: transport the child to Lexington. This was a medical emergency requiring specialists. Luna Fugate Combs, exhausted from delivery, terrified for her newborn son, made a decision that would change everything. She told them the truth. "He's not sick," she said quietly. "He's a fugate." The medical staff didn't understand. "It runs in my family," Luna explained. "The blue. It's been in the family for generations. My father was blue, my grandfather. It's just what we are." This statement, this calm assertion that a shocking medical abnormality was simply a family trait, should have triggered immediate investigation. But this was 1948. Medical genetics was in its infancy. The connection between DNA and heredity had been proven only 5 years earlier. The structure of DNA wouldn't be discovered for another 5 years. The concept that skin color could be inherited through some invisible genetic mechanism was revolutionary. The Lexington doctors examined Benjamin. They took blood samples. They documented his coloration with photographs. They tested his oxygen levels normal, his circulation normal, his heart normal. He was perfectly healthy. He was just blue, the doctors conferred. They searched medical literature. They found references to methemoglobinemia, a condition where hemoglobin in the blood is chemically altered and can't carry oxygen efficiently. But methemoglobinemia was usually acquired, caused by exposure to certain chemicals or drugs. It was also usually fatal in the concentrations needed to produce such dramatic skin color. Benjamin Stacy was thriving. After 2 weeks of tests, the doctors released him home with his mother, noting in his file, "Congenital methemoglobinemia, etiology unknown. Patient appears healthy despite presentation. Recommend follow-up." The follow-up never happened. Luna took her blue son home to Ball Creek, back to the hollers where blue children had been born for 6 generations, and Benjamin Stacy grew up healthy, strong, and blue. But the blood samples remained in Lexington, the photographs remained, the documentation remained. And 13 years later, a young hematologist named Madison Coween-Roman III would see them and become obsessed. Madison Coween-Roman III was not from the mountains. He was from Lexington, educated at the University of Kentucky, trained in the emerging field of hematology, the study of blood. In 1961, he was 27 years old, ambitious, fascinated by medical mysteries. When he encountered the Fugate files while researching inherited blood disorders, his reaction was immediate and visceral. This was impossible. People could not be blue and healthy. The physiology didn't work. If your blood couldn't carry oxygen efficiently, which is what the blue color suggested, you died. Or at best, you were severely disabled, unable to perform normal physical activities. Yet the reports described manual laborers, farmers, people living full lives in the demanding environment of mountain Kentucky. Some had lived into their 80s and 90s. Coween became convinced he was looking at a new disease, or rather, a very old disease that had somehow been missed by modern medicine. He began to plan an expedition, not to a distant country, not to some tropical wilderness, but to Perry County, just 100 miles from his laboratory. 100 miles that might as well have been 1,000, because the hollers of Troublesome Creek existed in a different temporal zone, operating by different rules. But Coween needed a guide, someone who knew the mountains, who could navigate the social complexities of closed communities, suspicious of outsiders. He found that guide in a nurse named Ruth Pendergrass. Ruth had grown up in the mountains. She knew the families, knew the hollers, knew how to approach people who'd been burned by government officials and medical professionals who came with promises and left with nothing but invasive questions and broken trust. Together, in the summer of 1961, they drove into Perry County searching for blue people. The first challenge was finding them. The Fugates and their relations didn't exactly advertise. After generations of being gawked at, whispered about, turned into folklore, the Blue families had learned discretion. They knew who they were. They didn't need outsiders confirming it. Ruth Pendergrass started by visiting churches. In mountain communities, churches were social centers, information hubs, places where trust could be established. She explained that a doctor from Lexington was trying to help, trying to understand the condition, maybe even cure it. The reactions were mixed. Some families refused outright. "We don't need help." One matriarch told Ruth firmly, "We've been this way for 100 years. We'll be this way for 100 more. We don't need city doctors treating us like experiments." Others were curious but cautious. "What kind of help?" they asked. "What would we have to do?" And a crucial few, were willing to talk. The first breakthrough came from a woman named Rachel Combs, a distant cousin of Luna Fugate Combs. Rachel's husband was blue. Not dramatically blue like some of the older generation, but noticeably blue. Skin with a definite grayish blue tint, especially visible in his lips, fingernails, and the creases of his palms. His name was Patrick Combs, and he was 2 years old, a retired coal miner who now farmed a small plot on Ball Creek. Ruth arranged a meeting. Coween would never forget the moment he first saw Patrick Combs. In his later interviews, he described it with scientific precision. The cyanosis was evident immediately upon visual examination. The patient's skin presented with a slate, blue coloration most prominent in the extremities and mucous membranes. However, the patient was ambulatory, alert, and showed no signs of respiratory distress. In other words, Patrick was blue. And Patrick was fine. Coween explained his theory. He believed the family suffered from a genetic condition that affected their blood's ability to carry oxygen. With Patrick's permission, he drew blood samples. The blood was wrong. Normal human blood, when oxygenated, is bright red. Deoxygenated blood is darker, more purple, red. Patrick's blood was brown, a distinct chocolate, brown that looked nothing like what should be flowing through human veins. Coween rushed the samples back to his lab in Lexington. Under the microscope, Coween found his answer, or at least part of it. Patrick's blood contained abnormally high levels of methemoglobin. Normal blood contains less than 1% methemoglobin. Patrick's blood was 15 to 20% methemoglobin. Methemoglobin is a form of hemoglobin that cannot bind oxygen. It forms naturally in the body at low levels, but is normally converted back to regular hemoglobin by an enzyme called methemoglobin reductase. Patrick's blood suggested his body wasn't producing enough of this enzyme. Without it, methemoglobin accumulated. And methemoglobin, unlike the bright red oxygenated hemoglobin, is brown. When you see it through the skin, it appears blue. This explained the color, but it didn't explain why Patrick was healthy. People with acquired methemoglobinemia from chemical exposure or drug reactions died when their methemoglobin levels reached 20%. Their blood simply couldn't carry enough oxygen to support life. Yet Patrick had been doing manual labor his entire life. Mining coal, farming, he'd raised 7 children. He'd lived more than 6 decades. The answer, Cowen realized, was adaptation. Patrick's body had compensated. His red blood cell count was higher than normal more cells to carry the oxygen his methemoglobin. Heavy blood struggled to transport. His heart was slightly enlarged, pumping harder to circulate blood efficiently. His lungs functioned at peak capacity. His body had built redundancies, backup systems, physiological workarounds. It was elegant. It was remarkable. And it suggested this condition had been present for so long that natural selection had optimized the bloodline for survival despite it. Cowen needed more subjects, more blood, more data. Ruth Pendergrass helped him find them. Over the next 6 months, Cowen and Pendergrass identified and tested over 60 people connected to the Fugate bloodline. They discovered the pattern. The gene was recessive, to be blue. To express the trait visibly, you needed 2 copies, one from each parent. The gene was incredibly rare in the general population, but had been amplified through generations of intermarriage in the isolated Perry County community. The degree of blueness varied. Some individuals were dramatically blue. Others showed only slight discoloration. The variation seemed to depend on the exact mutation and on environmental factors, diet, altitude, exposure to cold. The trait was benign. Despite appearances, the blue people were healthy. Their life expectancies matched or exceeded the regional average. Some had lived into their 90s. Cowen traced the lineage back through county records, census data, family Bibles, and oral histories. Everything led back to Martin Fugate and Elizabeth Smith. That impossibly rare meeting, that chance encounter of 2 people carrying the same incredibly uncommon recessive gene. Their marriage, their children, and then the compounding effect of isolation. Children marrying 3rd cousins, 4th cousins, families intertwining over 6 generations until the gene pool was less a pool and more a puddle, concentrated and closed. By 1961, Cowen estimated roughly 1 in 5 people descended from the original Fugate line carried the gene, and in some families, nearly half the children born showed the blue coloration. This was, genetically speaking, extraordinary. A textbook case of the founder effect combined with genetic drift in an isolated population. But for Cowen, it was also an opportunity. If he could treat this, if he could find a way to restore the blood to normal, he would make medical history. And more importantly, he could give these families a choice they'd never had before, the choice to not be blue. The answer came from studying the biochemistry of methemoglobin reduction. In normal humans, the enzyme methemoglobin reductase converts methemoglobin back to regular hemoglobin using a cofactor, a chemical helper, called NAD. The Fugates didn't produce enough of the enzyme, but Cowen wondered, what if he could supplement the cofactor directly? What if he could chemically push the reaction to proceed even without adequate enzyme levels? There was a drug that might work, methylene blue. Methylene blue is a dye, a chemical used in laboratories and in certain medical treatments. It has a unique property. It can act as an artificial electron acceptor, essentially doing the job of the missing enzyme and forcing the conversion of methemoglobin back to hemoglobin. Cowen had used it before to treat patients with acquired methemoglobin, people poisoned by nitrites or certain drugs. It worked quickly and dramatically, but would it work on a genetic condition, on blood that had been blue for generations? There was only one way to find out. In December 1961, Cowen returned to Ball Creek with a vial of methylene blue solution and the consent of Patrick Combs to try an experimental treatment. Patrick sat in his kitchen, surrounded by family members who'd gathered to watch. some were skeptical. Some were hopeful, all were curious. Kaween administered the injection, and then they waited. The change began within minutes. Patrick's wife noticed it first. "Your hands," she said quietly. "Patrick, look at your hands." The blue was fading. It started at the fingertips, the color draining away like water receding, revealing pink skin underneath. The change spread, up his arms, across his face, down to his toes. Within 90 minutes, Patrick Combs was no longer blue. For the first time in 62 years, his skin was the pale pink of his European ancestry. Normal, unremarkable, human in the way society expected human to look. The family was silent. Then someone started crying. Not Patrick. Patrick sat very still, staring at his hands as if they belonged to someone else. But his daughter, one of his blue children, was weeping quietly. "Daddy," she said, "you look like everyone else." Kaween explained that the effect was temporary. The methylene blue would be metabolized and excreted. Within a few days, maybe a week, the blue would return. But if Patrick wanted, he could take regular doses pills, easy to administer. That would keep the color permanently at bay. Patrick considered this. His wife waited. Finally, Patrick spoke. "I appreciate what you've done, Doc," he said slowly. "I truly do, but I don't think I want to take pills for the rest of my life just to look different than I've looked for 62 years. I know who I am, my family knows who I am, and I've been blue all this time. I reckon I can be blue a while longer." The blue returned within 5 days. Patrick Combs never took another dose of methylene blue. But others did. News of the cure spread through the extended family network. Younger Fugates, people who'd endured decades of stares and whispers, people who wanted to move to cities where anonymity required blending in, people who were tired of being different. They came to Kaween asking for treatment. Kaween provided it, along with prescriptions for regular oral doses of methylene blue that could maintain normal skin tone indefinitely. Some chose to take it. A young woman named Shirley Fugate, preparing to move to Cincinnati for a nursing job, decided the treatment would make her life easier. She took the pills religiously. Her blue faded. She moved to the city, and no one there ever knew she'd been born a different color. A teenager named Dennis Stacy, tired of being bullied in school, begged his parents to let him try the treatment. They agreed. Within a month, he looked like any other kid in Hazard High School. The bullying stopped. But many others chose to remain blue. They'd lived this way their whole lives. The blue was part of their identity, their family history, their connection to generations past. Taking pills to change it felt like erasure, like admitting there was something wrong with them that needed fixing. "I'm not sick," one woman told a reporter years later. "I was born blue, my daddy was blue, my granddaddy was blue. It's just who we are. Why should I change that?" It was a profound question, one that medicine, in its rush to cure and normalize, often failed to ask. Who decides what needs fixing? The story broke nationally in 1963. Science magazine published Kaween's findings: hereditary methemoglobinemia in an isolated population, the Fugate family of Kentucky. The article included photographs with the family's permission showing the dramatic blue coloration and its reversal with methylene blue treatment. The response was immediate and overwhelming. Newspapers sent reporters to Perry County. Life magazine requested permission to photograph the family. Television stations wanted interviews. The Fugates, after 6 generations of isolation and privacy, were suddenly famous. Most of them hated it. Reporters invaded the hollers, knocking on doors, demanding stories, treating the blue people like circus attractions. Camera crews set up on private property without permission. One tabloid ran a headline, "The Real Smurfs," America's Blue family revealed, the exploitation was painful, dehumanizing. Several families stopped answering their doors, stopped talking to outsiders entirely. The brief window of cooperation closed, but the scientific knowledge was out. Kawin had documented the condition, traced its genetics, provided a treatment option. The mystery was solved. Methemoglobinemia due to deficiency of cytochrome B5 reductase in an isolated population with a founder effect and amplification through consanguineous marriage. In medical terms, it was elegant, a perfect case study of genetics, isolation, and adaptation. In human terms, it was more complicated. Modern genetic analysis, conducted in the 1990s and 2000s, filled in the remaining details. DNA testing confirmed that Martin Fugate and Elizabeth Smith had both carried a specific mutation in the CYP5A1 gene. The mutation is now designated as the Fugate variant. It appears nowhere else in the world with any frequency. Researchers traced Martin's lineage back to France and found scattered historical references to pale or unusual family members, but no concrete evidence of blue coloration. Either the trait had been suppressed by outbreeding before Martin's birth, or he was the first to carry two copies. Elizabeth's lineage was traced to early Irish settlers in Pennsylvania. Her family had migrated south into Appalachia in the mid-1700s. Somewhere in that lineage, the same mutation had occurred independently, or perhaps she had distant French ancestry that reconnected the bloodlines after centuries of separation. The odds of this happening randomly are effectively zero, which means it wasn't random. Statistical improbability, when it manifests in reality, points to hidden connections, forgotten relationships, intertwined histories we can no longer trace. Martin and Elizabeth were almost certainly distant relatives, fifth cousins, eighth cousins, related through some marriage 3 or 4 generations back that no one remembered or documented. The genes remembered, and when those genes combined in their children, the recessive trait expressed itself with full intensity. Benjamin Stacy, the bluest baby ever documented, the child whose dramatic coloration had first brought university doctors into the hollers, grew up healthy and strong. His blue faded as he aged. This was unexpected but explicable. As Benjamin matured, his body produced more red blood cells, developed more efficient circulation. The methemoglobin levels decreased slightly. The blue became less intense. By the time he was 7, he looked merely bruised, a grayish tint rather than the deep indigo of his infancy. By the time he was a teenager, only his fingernails and lips showed the telltale blue. Benjamin's case revealed something crucial. The severity of the condition varied with age, with overall health, with environmental factors. It was not fixed. It was dynamic, responsive to the body's changing chemistry. This gave hope to parents of blue children. Their kids might grow out of the most dramatic coloration even without treatment. But Benjamin's gradual normalization also meant something else. The trait was fading from the bloodline. The roads that came to Perry County in the early 1900s brought more than just physical connection to the outside world. They brought new bloodlines. Young people left the hollers for work, for education, for the allure of cities where opportunities existed beyond subsistence farming. When they returned, if they returned, they often brought spouses from outside the county, outside the closed genetic network that had preserved and amplified the Fugate gene. This was healthy. This was normal. This was how genetics should work. Mixing, diversifying, spreading risk across a wider population. But it also meant the end of the blue people. Each generation that married out diluted the gene. Children born to one blue parent and one genetically normal parent would not be blue. They'd be carriers, invisible, indistinguishable from anyone else. The trait would continue to exist in the bloodline, hidden, waiting, but it would express itself less and less frequently. By the 1970s, there were no longer any dramatically blue fugates. The last intensely blue individual, a woman named Luna Fugate, died in 1982 at the age of 84. Her obituary mentioned she was a member of the Methodist Church, survived by 6 children and 14 grandchildren. It did not mention she had been blue. By the 1990s, genetic testing of fugate descendants showed that while the gene persisted, roughly 1 in 8 family members still carried 1 copy, no one carried 2 copies. No one expressed the trait. The last blue fugate had passed. The genetic legacy remained, waiting in the bloodlines of hundreds of descendants scattered across America. But visible blueness had vanished. The roads that connected the hollers to the wider world had finally done what nature alone could not. They had eliminated the isolated gene pool that made the blue people possible. Today, if you drive into Perry County, into the hollers along Troublesome Creek, you can still find descendants of the fugate line. They look like everyone else. The geographic isolation that preserved the blue gene has been erased by highways, internet, cell phone towers. Young people stream Netflix in hollers that once went months without seeing outsiders. They order from Amazon. They leave for college and sometimes come back, sometimes don't. The old cabins where blue children were born have mostly collapsed or been replaced with modern homes. The one-room churches where fugates married their cousins have been torn down or converted into community centers. But memory persists. Talk to older residents, people in their 70s and 80s, and they remember. They remember grandparents who were blue. They remember children in school with that strange grayish tint. They remember the stares, the whispers, the cruel nicknames. Some remember with shame. They participated in the cruelty, the exclusion, and now they regret it. Others remember with something closer to wonder. They were just different. One woman told an interviewer in 2006, "Not bad different, just blue. You got used to it. After a while, you stopped seeing the color and just saw the person. The scientific legacy is secure." Madison Coween's research paper is cited in medical genetics textbooks. The fugate case is taught in university courses on population genetics, founder effects, and the importance of genetic diversity. Medical understanding of methemoglobinemia has advanced significantly. We now know there are multiple genetic variants that can cause it, not just the fugate mutation. We understand the biochemistry in exquisite detail. Treatment protocols exist for acquired cases. The fugates gave science a gift, a natural experiment in human genetics that could never be deliberately created, that revealed profound truths about inheritance, adaptation, and the power of isolation to shape biological destiny. But what did they receive in return? In 2019, a genetics research team from Johns Hopkins decided to conduct follow-up studies on the fugate descendants. With modern DNA sequencing technology, tools that didn't exist in Coween's era, they could map the exact mutations, understand the molecular mechanisms, potentially identify other carriers worldwide. They began by searching for living descendants willing to participate. The response was mixed. Some family members were eager. They wanted to understand their heritage, contribute to science, connect with their unusual history. Others refused. "We've been studied enough." One descendant told the researchers, "We're not lab rats. We're people. Our family's medical condition isn't a curiosity for your career advancement." The tension was real. The fugates had been treated as oddities, as freaks, as scientific specimens for so long that many descendants wanted nothing more than to be left alone. The Johns Hopkins team eventually recruited 3 volunteers. DNA analysis confirmed the presence of the Fugate variant in 11 of them. Statistical modeling suggested the gene exists in approximately 300 to 500 people currently alive, scattered across the United States. None of them are blue. To express the trait, 2 carriers would have to meet and have children. In the modern, mobile, genetically diverse American population, the odds are infinitesimal. The blue people are gone. But they are also everywhere invisible carriers of a genetic legacy that connects them to a French orphan who arrived in Kentucky 200 years ago carrying a secret in his blood. Despite all the research, despite genetic sequencing and biochemical analysis and exhaustive family tree reconstruction, mysteries remain. Why did Martin Fugate come to Kentucky? We don't know. The records don't say. He was an orphan in France, and then he was a settler in Appalachia, and the journey between those 2 facts is blank space. Was he fleeing something, seeking something? Was his orphanhood, and therefore the lack of family to pass on his medical history, itself significant? Why did Elizabeth Smith carry the same rare mutation? Statistical improbability suggests hidden ancestry, forgotten connections. But we can't prove it. The genealogical records don't go back far enough, or were never kept in enough detail, or were lost in courthouse fires and floods and the general erosion of memory. The math says they had to be related, but we can't show how. Did Martin know he was different? In France, before he emigrated, did he see other blue people? His parents, siblings, is that why he left? To escape persecution, to seek a place where his strangeness might go unnoticed in the broader strangeness of frontier wilderness? Or did he have no idea what he carried? Was the blue a complete surprise when his first child was born? We'll never know. Martin left no letters, no diary, no explanation. How many other isolated populations carry similar secrets? The Fugates became famous because researchers found them, because Cowen was persistent, and Ruth Pendergrass was patient, and the timing was right. But how many other genetic anomalies exist in isolated communities around the world, never documented, never studied, just living their lives in quiet difference? What was lost when the blue faded? This is perhaps the most philosophical question. The Fugates were unique. Their existence was improbable, their genetics remarkable, their adaptation extraordinary. When the last blue Fugate died, something irreplaceable vanished from human diversity. Should we mourn that, or celebrate that they finally could blend in, finally could escape the burden of visible difference? There's no clear answer. Both responses are valid. The story of the Blue Fugates forces us to confront uncomfortable questions about difference, normalization, and the price of integration. Madison Cowen created a cure. He approached it from pure scientific curiosity and genuine desire to help. The methylene blue treatment worked. It was safe, effective, reversible if needed. But was it necessary? The Fugates were not sick. They were not suffering from medical pathology in any meaningful sense. Their bodies had adapted. They lived full lives. The only thing wrong with them was that they didn't look like other people. So when we offer a cure for that, when we create a pill to make different people normal, what are we really saying? Are we helping them, or are we telling them that difference is a problem, that deviation from the norm requires correction, that visibility equals disability? This is not an academic question. We face it constantly in modern medicine. Genetic screening for conditions that don't affect lifespan or quality of life, but do affect appearance. surgeries to correct variations in anatomy that function perfectly well but don't match societal expectations, therapies to normalize people who are healthy but different. Where do we draw the line? The Fugates themselves gave us different answers. Some chose the cure, some chose to remain blue. Both choices were valid. Both reflected different ways of understanding identity, community, and the meaning of health. But here's what troubles me about this story, what keeps me awake at night, thinking about those mountain hollers and that impossibly rare gene. The Fugates didn't disappear because they wanted to. They disappeared because the world around them changed, the isolation broke, the gene pool mixed. The conditions that created them were erased by highways and television, and the slow, inexorable spread of modern connectivity. Was this progress? Undoubtedly. Isolation is dangerous. Genetic diversity is healthy. No one should argue for preserving closed communities just to maintain unusual traits. But something was lost. A 200-year genetic experiment ended. A unique expression of human biology vanished. And we can never get it back. The Fugates existed at the intersection of chance, isolation, and biology. They were an accident of history, but what a remarkable accident. They showed us that humans can adapt to conditions that should be fatal. That appearance and health are not the same thing. That communities can, sometimes, accept profound difference if given no choice but to adapt. And they showed us that difference itself is temporary. Given time, given connection, given the mixing of bloodlines and cultures and geographies, everything eventually homogenizes. The unusual becomes average, the blue fades to pink. Is this good, bad, both, neither? I think it's just change. Inevitable, relentless, value-neutral change. But I also think it's worth mourning. Not the genetic condition itself. Methemoglobinemia is not something to preserve for its own sake, but the uniqueness, the irreplaceability, the fact that there once existed, in the mountains of eastern Kentucky, families whose blood ran blue, who lived and loved and raised children and survived despite everyone saying they couldn't, shouldn't, wouldn't. They were remarkable, and now they're gone. And in their absence, we're left with questions about what we lose when we cure difference, when we normalize outliers, when we smooth the rough edges of human diversity. I want you to imagine something with me. It's 1825. You're standing outside a cabin on Troublesome Creek. The mountains rise on all sides, close enough to touch. The valleys so deep that stars appear at midday in the shadowed hollows. The air smells of wood smoke and pine sap, and the metallic tang of creek water over limestone. Inside the cabin, a woman screams. It's childbirth. Dangerous always, potentially fatal in this time and place where doctors are scarce and hospitals non-existent. But the midwife knows her job. The baby emerges, takes its first breath, begins to cry, and in the lamplight, in the flickering orange glow of fire and candle, the midwife sees the child's skin. Blue. For just a moment, there's absolute silence. The kind of silence that comes when reality breaks all expectations, when what you're seeing contradicts everything you believe possible. Then the mother speaks, "Let me see my child." The midwife hesitates, but places the baby in its mother's arms. Elizabeth Fugate, because this is one of Martin and Elizabeth's blue children, one of the first, one of the earliest manifestations of the impossible gene, looks down at her blue infant and makes a decision that will echo through generations. She doesn't scream, doesn't reject the child, doesn't believe it's cursed or demonic or evidence of God's displeasure. She holds the child close and begins to sing. A French lullaby that Martin taught her, that his mother sang to him, that came across an ocean and survived translation, and now gets whispered to a blue baby in a Kentucky holler while darkness presses against the cabin walls. The baby stops crying. The blue doesn't fade. It never will. But the child is loved, is kept, is raised. And that choice, that simple, profound choice to accept what cannot be explained, to love what cannot be changed, to see past color to the human beneath, that choice is the real story. Not the genetics, not the science, not the cure that would come 135 years later. The real story is how a community, faced with the impossible and the inexplicable, chose acceptance, sometimes reluctantly, sometimes with cruelty and exclusion that we must not ignore or excuse. But fundamentally, ultimately, they chose to let the blue people exist, to be, to survive, and the Fugates, in turn, chose to stay. They could have left the mountains, could have sought anonymity in cities, could have hidden their difference. They stayed, they raised families, they built lives. They were blue, and they were human, and for 6 generations those two facts coexisted in the hollers of Troublesome Creek, until the modern world arrived and made the distinction obsolete. If this journey through the impossible biology and improbable history of the Blue Fugates resonated with you, if you find yourself thinking about what it means to be different, to be visible, to carry in your blood a legacy you never chose, then this channel has more truths waiting for you. Subscribe if you're willing to explore the places where science intersects with human story, where genetic accident becomes family identity, where the inexplicable becomes simply the way things are. Leave a like if this account made you question what we mean by normal, what we lose when we cure difference, and whether progress always moves in the direction we think it does. And in the comments, I want to know, if you carried the Fugate gene, if you knew that you and your children might be born blue, would you choose the cure? Would you take the pills to look like everyone else? Or would you embrace the difference, the uniqueness, the connection to a 200-year bloodline that existed nowhere else on Earth? There's no right answer. The Fugates themselves couldn't agree on one, but the question matters, because we all carry something, genetic, cultural, experiential, that makes us different. And we all face the choice: do we hide it, cure it, normalize it, or do we claim it, own it, let it be part of what makes us remarkable? The Blue Fugates chose both. Some took the cure, some remained blue. Both choices were acts of agency, of self-determination, of deciding for themselves what their identity would mean. That's the real legacy, not the genetics, the choice. Until next time, remember, the most remarkable stories are often the ones that force us to reconsider what we thought we knew about normal, about health, about the infinite variations of being human. And sometimes, the most beautiful thing we can do is simply bear witness to difference without demanding it change. The Blue Fugates were blue, and they were enough, exactly as they were.